Thank you for the opportunity to present our data on BDNF and DRD2 molecular genetic influences on alexithymia. So at first, what is alexithymia? From the origin of the word, which is from the Greek, alexithymia means that you have no words for your feelings or emotions, and it refers to difficulties in emotional self-regulation. And it has been identified as a personality construct. And as a personality construct, it is highly correlated, of course, negatively with emotional awareness and positively with anxiety-related traits like harm avoidance or neuroticism. And it has been identified as a risk factor for several mental disorders like panic disorder or somatization or anorexia nervosa. The key characteristics of alexithymia are difficulties or incapacities to experience emotions, to verbalize emotions, to fantasize, to think about one's own emotions and to identify them. And alexithymic people have difficulties to reach conscious awareness over their emotions, and they have no voluntary control over them. So an alexithymic person who is, for example, angry would feel that his or her muscles tense up, that the heart rate accelerates, and that the rate of breathing increases, but he won't find a word for his physical responses, so he can't say, I'm angry. So alexithymic people have autonomic and sensory normal responses, but there's a lack of conscious emotional experience. Of course, research is focused on identifying brain areas which are involved in alexithymia and or altered brain activities in specific areas to be linked to alexithymia, and it can be suggested that the anterior cingulate cortex plays a crucial role because the cerebral blood flow in the ACC has been positively linked to conscious awareness of cognitive stimuli, and the ACC is a part of the limbic system and involved in monitoring functions in case of conflicting brain activity. And there are PET studies that found, on the one hand, a positive correlation between the CBF and the ACC and emotional awareness, and on the other hand, a negative correlation between alexithymia and the CBF in the ACC during the processing of emotional stimuli. Besides alexithymia, a reduced gray matter volume in the ACC has been linked to mental disorders like depression, PTSD, or addiction. So recent findings from our own work group have found a significant interaction between two prominent polymorphisms on gray matter volume in the ACC. So there's an interaction between the BDNF Y66MET and the DRD2 ANKK1 TAC1A polymorphism, who has a significant influence, and carriers of at least one MET allele of the BDNF polymorphism, who also carry at least one A1 allele of this DRD2 TAC1A polymorphism, exhibit the lowest gray matter volume in the ACC. And an additional study has found out that these carriers of these two different allelic configurations show the highest harm avoidance and the lowest novelty seeking scores. So what is BDNF? BDNF is short for brain-derived neurotrophic factor, and this modulates dopaminergic pathways, and it influences processes in cell growth and apoptosis, so it plays a crucial role for neuroplasticity. The polymorphism under investigation is located on chromosome 11, and it is determined by an amino acid exchange from valine to methionine. So there are the three possible genotypes, VAL, VAL-MET, and MET-MET. And carriers of at least one MET allele show a decreased activity-dependent BDNF secretion in midbrain structures. So the MET genotype has been associated with higher higher trait anxiety, and carriers of the MET allele show a higher amygdala activation to all kinds of emotional stimuli. The DRD2 is short for dopamine receptor D2, and this polymorphism is located on chromosome 11q. There are also 3 possible genotypes, and this A1 allele is associated with a 40 to 30% reduced D2 receptor density compared to the A2 genotype. So, and the A1 allele is associated with higher drug and, of course, alcohol addiction. And as you can see, both polymorphisms under investigation have been shown to be functional. So, just to sum up, alexithymia has been associated with a reduced activity of the ACC during emotion processing, and alexithymia is positively correlated with anxiety. Both polymorphisms under investigation, and of course the carriers of the MET allele and the A1 allele, show the lowest gray matter volume in the ACC, and in addition have the highest harm avoidance and the lowest novelty-seeking scores. So we hypothesized that the interaction between these 2 polymorphisms would contribute to explain variance in alexithymia, and we hypothesized that carriers of this allelic configuration MET plus A1 plus have the highest alexithymia scores. So what we did is we genotyped 664 Caucasian healthy participants, and we genotyped them with real-time PCR for the 2 polymorphisms under investigation. And all participants filled in the TAS20 questionnaire, which is the Toronto Alexithymia Scale, and this is the most widely used questionnaire for measuring alexithymia. And it consists of 3 different subscales: the difficulties identifying feeling scale, the difficulties describing feeling scale, and the externally oriented thinking scale. And all participants filled in the TCI questionnaire, but in the light of this study, only harm avoidance and novelty seeking are of interest. And we conducted analysis of covariances with the dependent variable, of course, TAS20 and this, the overall score and the subscale scores, and and we grouped our participants into MET plus carriers of this BDNF polymorphism and non-carriers of the MET allele, and in A1 plus carriers of the DRD2 TAC1A polymorphism and non-carriers. And we entered age as a covariate in each analysis, because in our sample age was negatively correlated with alexithymia scores. And in additional analysis, we entered harm avoidance and novelty seeking as a covariate, but I will come back to that later. So at first, just to show you our genotype frequencies, all were in Hardy-Weinberg equilibrium, and gender was equally distributed across our 4 allelic configurations, so everything is okay. And as you can see in the table, on a descriptive level, you can see that the A1 plus MET plus group has the highest scores in the TAS20 overall and in all 3 subscales. So this is just a descriptive table. So we found a significant interaction between the MET, BDNF MET plus, MET minus, and the DRD2 A1 plus, A1 minus groups on the TAS20 overall score. And this interaction was significant on all our 3 TAS20 subscales. But only the interaction on the overall score and on the subscale difficulties identifying feelings was robust against the correction for multiple testing. So we had the specific hypothesis that carriers of the MET plus A1 plus group have the highest TAS20 scores, and so we conducted post-hoc t-tests to test for this. And we found that MET plus A1 plus carriers had higher scores than MET plus A1 minus carriers and then A1 plus MET minus carriers, but it was not higher than A1 minus MET minus carriers. But on a descriptive level, this is true. As I mentioned before, alexithymia was positively correlated, highly correlated with harm avoidance, and negatively correlated with novelty seeking in our sample. And so the question that arises here is if this interaction between BDNF and DRD2 just contributes to explain the shared variance of alexithymia, harm avoidance, and novelty seeking. So we conducted additional covariance analysis to control for harm avoidance and novelty seeking scores. And we found again a significant interaction between these two polymorphisms on the TAS20 overall score and on the subscale difficulties identifying feelings. So as you can see, the effect is a little bit weaker, but it's still highly significant. So we conclude that the BDNF VAL66MET and DRD2 ANKK1 TAC1A polymorphism interaction contributes to explain variants in alexithymia, and our hypothesis was true that MET plus A1 carriers show the highest alexithymia scores. Furthermore, our findings support the hypothesized link between dopamine and neurotrophic relevant genetic dispositions and altered gray matter volume in the anterior cingulate cortex. And our findings are in line with the conceptualization of alexithymia as a disruption between autonomic and sensory responses on the one hand and conscious emotional experience and responses on the other. So this is just a possible explanation of the interplay between the two polymorphisms under investigation and stimuli processing in the ACC and alexithymia. So what we already know from studies is that dopaminergic neurons in the ventral tegmental area and their projections to the nucleus accumbens play a crucial role for identifying emotional stimuli. And among others, cingulate cortices receive the most marked innervation from the VTA. So, as I mentioned before, the MET plus carriers of the BDNF polymorphism show reduced activity-dependent BDNF secretion in midbrain structures. And this may lead to a reduced activation of dopaminergic neurons in the VTA. And additionally, the A1 plus carriers of the DRD2 polymorphism have a reduced D2 receptor density. So together, it may be that dopaminergic pathways might be less activated, and this may lead to a reduced activation of the ACC via the mesocortical dopaminergic pathway. And as a result, it can be suggested that this contributes to a deficient or impoverished conscious emotional awareness. Okay, I'm in the end. I want to say thank you to my colleagues, Christian Montag, Sebastian Marquette, Andrea Felten, and Martin Reuter. And of course, I want to say thank you for your attention. Are there any questions?